Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 11 students in MCR 3U who are working on studying for the exam. It's video number 2 where I take up the solutions to the practice exam. And in this video we're going to look at question 16 in which you're writing sinusoidal equations. So 16a, for each graph, write a corresponding equation in terms of sine. So we know that we're looking for an equation that looks like this. And I'm hoping these are the letters you used in class. These are the letters I remember using, maybe. Sure. So we need to figure out the vertical stretch or compression, the vertical translation, the horizontal translation, and because it's sinusoidal, we need to figure out the period change. So a normal sine graph, our lovely best friend, the sine curve, looks like this. And we know that normally, without a transformation, it goes from 1 to -1. So it has a range of 2, and that normally tells us that our a value is half of that. So our a value is always half of the range. So on this graph, we go from +7 to -7. So instead of going from -1 to 1, we go from -7 to 7. That gives us a range of 14, which means that our a value is 7. So we go from 0 to 7 to the maximum and 0 to -7 to the minimum. Now, not only do I now know that the a value is 7, but I also know that this graph has not been vertically translated. The midpoint of the maximum and the minimum is right at 0, which means that plus c is actually plus 0. In other words, there is no vertical translation. So that's how you find A and C. Now let's talk about the inside changes or the horizontal changes. Normally a sine curve from the starting point here to the end point here fits into a full circle, which is 360 degrees. Let's look at what this graph does. So if I start here, this is the start of a good sine curve. I'm at 30 degrees, and then go up, down, and up, and I stopped at 210 degrees. So again, the starting point here, which is at 30, and the end point of one cycle here at 210. So that means 210 minus 30, that I have a period of 180 degrees. So the period is supposed to be 360, and it's not. So that means we've had a period change, and because there's a period change, I have to find what k is. So the formula is that the period is equal to 360 divided by k. So we know in this case that the period is 180, so we can solve for k, do a little cross multiplication, or we just know that k is 2. So one way of thinking about that value, what does it mean to say k is 2? It means that in the normal space it takes to fit one cycle, so normally it takes 360 degrees to do one cycle, we can now fit 2 cycles. That's what k equals 2 means. Another way is to think about it is that we cut the period in half. So now we know what the k value is, and then finally the d value. Well, the starting point of a sine curve is supposed to be at 0. In this case, our starting point was here at 30. So that means we went to the right by 30. And if we go right by 30, we say -30. So let's formalize this all and write it as a final answer. So we have y equals, the amplitude was 7, the k value is 2, we moved to the right by 30, and there wasn't any vertical translation. So there's the answer to 16a. And I guess I should put a little degree symbol here, whatever. So now let's do the same thing with 16b. So again, it's supposed to be a sine curve. So first of all, the maximum's at 5. Is that 5? No, 6. And the minimum's at -2. So we go from 6. Oops. Oh, I hate when that happens. Hold on. I hate when that happens. Okay, so we go from 6 to -2. So the range is 8, and half of the range is 4. So the amplitude is 4. So now I know that A equals 4. I also know that the midpoint between 6 and -2, the midpoint is 2. So I now also know that the middle axis is at 2. And again, you can either do that using midpoint or just by eyeballing 6 minus 4, -2 plus 4, I get to that midpoint value. So now I know that the C value is 2. So I've moved this up 2. So there's all of our vertical changes. Now let's look horizontally. So let's say, well, I could say that this is the start of a sine curve here, in which case we would have negative sine. So let's do that. Let's say that our sine curve starts here, and then we go negative, and then positive. So in this case, we see a period. If we start at 0 and we end here, the period is 120, and therefore 120 equals 360 over k. So if you want to cross multiply, 120 times k is 360. Divide by 120, k equals 3. So there's the k value. And again, because we decided to use this as our starting point and make it negative sine, I don't see any phase shift. There's no horizontal translation. You could have started your sine curve here and done positive sine with a phase shift of right by 60. But we prefer not to have phase shift if we can avoid them. So instead, that's why we decided to go with negative sine. So it was negative 4 sine, the k value is 3, and oh, we didn't move it left or right, but we did move it up by 2. And obviously I have a lot of extra brackets here that I don't need, so we could just simply write this like this. And you can see that there's no phase shift, so you don't need all those brackets. So I hope that helped with question 16. Obviously being able to find the equation of a sine curve was a major component of the course, and hopefully it's all pretty straightforward. All right, so that was the second video, and I'll move on and do question 17 in the next video. Bye-bye.